comes the next important, most expected question for the upcoming exam. Mention the differences between the series and parallel circuits. Even though the question seems to be very simple, when you write the answer in exam, you have to be very specific. So let us see what are the differences between the series and the parallel circuits. Since the differences is among the circuits, its first difference will definitely be among its circuit diagram. As you can see in the diagram, it is very clear the three resistors are connected in series. The voltmeter is connected in parallel across the three resistors and the ammeter is connected in series with the battery. Since the plug key is closed, it ensures the current flow through the circuit. The arrow mark shows the flow of current from positive to the negative terminal. Coming to the parallel circuit, three resistors are connected in parallel, across which the voltmeter is connected in parallel and an ammeter is connected in series with the battery. Since the plug key is closed, it is confirmed the current is flowing through the circuit from positive to negative, which is the direction of conventional flow of current. No matter which is the circuit diagram we draw, the three main rules we have to keep in our mind is the voltmeter has to be connected in parallel, ammeter has to be connected in series, and the plug key has to be closed. Here comes the next difference. We are going to compare series and the parallel circuit with respect to voltage. With respect to voltage, we are going to be differentiating series and parallel circuit. It's the very important point. Voltage in the series circuit is going to be the sum of the voltages among each resistors. So the total voltage will be equal to V1 plus V2 plus V3, where V1 is the voltage across R1, V2 is the voltage across R2, V3 is the voltage across R3. Coming to the parallel circuits, here all the components will have the same voltage, which will be same as the total voltage through the circuit. That is V1 equals V2 equals V3. Voltage across the first resistor will be equal to the voltage across the second as well as the third. We have to remember this point. It's very important because this application we will be using while solving numericals also. Please let me know in the comment section for the detailed explanation about the formulas and their application in numericals. So we came to know the differences between series and parallel circuit. The first point was its circuit diagram. The next one was its comparison with respect to voltage. Here comes the next point. Current is constant in all the parts. That is, the current through the first resistor is equal to the current through the second, which is also equal to the current through the third resistor. So in a series circuit, current is constant. It is same among all the resistors. Earlier we had seen in parallel circuit, voltage was same. In series, current is same. We have to compare the parameter current with respect to series and parallel circuit. So what about current in the parallel circuit? The current is split between the branches. That is, the complete current or the total current will be equal to the sum of the currents flowing through the resistor 1, flowing through the resistor 2 and flowing through the resistor 3. That is nothing but I1 plus I2 plus I3. We are done with comparing voltage and current with respect to series and parallel circuit. The final parameter which we are supposed to compare is nothing but resistance. A very important topic, resistance. What about resistance in series and parallel circuit? You would have seen these formulas in our previous videos. If not, please check our description box for the formulas and their explanation. The resistance, the equivalent resistance of the resistors connected in series is obtained by the formula, that is adding all the three resistors. The equivalent resistance is obtained by adding all the individual resistances. In the same way, the equivalent resistance or the total resistance in the parallel circuit is obtained by taking the reciprocal of individual resistances and adding them.